So hello and welcome for my talk, Measure and Increase Developer Productivity with the Help of Serverless. I will be giving two talks in the cloud platform track. So the first one will be this, and the second will be quite different about Java and serverless adoption, but then in German. So my name is Vadym, and I'm one of the co-organizers of Java User Group Bonn, but also Serverless Bonn meetup. So Java and serverless are two my passions. I know that just everything depends on the problem that we are solving, but I'm quite a big believer of serverless in general. And I would like also to convince you to dive deeper. What are the advantages and just how you can take the advantage of this. You may write me questions via email or follow me on LinkedIn or Twitter. So I am only experienced in the AWS cloud provider. So there will be some examples which of course require some at least basic knowledge of AWS services. So I hope that it's not the reason for somebody who uses more Azure or Google Cloud to leave. So with this, we may start. So I'm currently working since 15 years for the company called IP Labs in Bonn. And we are writing the platform there, the software for editing, creating, and purchasing of the photo products like calendars, photo books, and so on. We are the 100% subsidiary of the Fujifilm Europe, based in Düsseldorf. We are based in Bonn, and since 17 years on the market. So probably you bought some kind of product from us or from our partners. We are a white label company, so something like photo book of the year and so on. We are completely in AWS cloud and using serverless very much, and I would say even as much as possible for our solutions. So, but before we dive deeper into serverless and how to measure and see if it's the right way, so let's take a step down and just let's talk about the challenges of the software development in general, just to write the big picture. And I really like this book, Team Topologies, which has been released, I think, nearly 2 years ago by Matthew Skelton and Manuel Pais. And they are talking about, if we are just writing software, of the cognitive load, and this is total amount of mental memory being used on just to implement the solution. And they differentiate three types of this: intrinsic, extraneous, and germane. And intrinsic is probably something very basic, and everybody should just embrace this. This is how to write a Java class or use some framework like Spring. So basic stuff that we are using on the daily business, and we cannot outsource this. So just we have to learn this and become productive. The second one, the things may become complicated. This is extraneous cognitive load. Just it's about how to automate the test, more complex stuff like integration end-to-end, maybe desktop, mobile, depending on what you're currently using. So how to deploy package, how to build, deploy package, and run your application, how to configure monitoring, alerting, auto-scaling, logging, and tracing. And many companies just building distributed application, microservices application, and just it's kind of issue. You can focus on all this stuff and just don't write your business logic. How to operate and maintain infrastructure. Let's decouple from the cloud. Cloud gives us the platform, but generally, if you do everything on your own, you have to take care about this. How to build fault tolerance and resilience in your application. And how to make hardware networking applications secure. And security is also the job number one. So you see quite a lot of challenges which every application need to deal with, just besides all the basic stuff and the problem we are solving. And the germane load, this is kind of difficult to remember term. It's about our domain knowledge. So where we're currently solving for solution, this is the business processes and workflows. For us at IP Labs is just to build the real cool editor that you can just create your products, to bring the content to help you just design it very quickly. But for us, is, for example, payment, e-commerce, it's not our core domain. So this is not where we just differentiate ourselves from other stuff, also from other companies. And just what the people are talking about, intrinsic cognitive load. So it's about how to become fluent in it. And externals, yeah, just minimize amount of what we implement, operate, and support by ourselves. It's required, but it's just maybe the solve problem or just the platforms that or cloud providers that may help you. And Germain, it's also minimize amount of what we have to implement by ourselves. So just focus on our core stuff and just use software as a service in case just it helps you. So generally, the question is about productivity. When we are productive, and we are productive if we regular ship products, so shipping, deploying things live, and of course, we should do right things so that it should be successfully used by our customers. But the next question is, what is holding us back from being productive? And just I refer to one of the reports, just the link below, and you will see this slides in the end. So these are the stuff that may hold us from being productive. And the first thing is technical debt. You see nearly 19% reflects that. And if you look into the Wikipedia, you will see technical debt reflects the implied cost of some not optimal solution. But we know that there might be a better approach and just we need to fix it on the longer run. So for me, it's just not the quite right definition, because even a perfect solution can become technical debt over time, and nearly all cases will be. For example, you are using the hottest programming language version, just like Java 17, and just it will become out of support. And just if you use JavaScript frameworks, you know the problem. And just you have to just update, and you will have to deal with not backwards compatible changes. So security consideration may force you to upgrade your dependencies as well. For example, just web application server version and so on. Just TLS 1.0 is the standard. So if you're just using something that only supports the TLS 1.1, just you have to upgrade, and sometimes later you will see that TLS 1.3 will become the standard. So we are constantly in this space of upgrading, and one of our dependencies, like open source project, may be discontinued, and just this what happened to us. We have to increase the security, just to strengthen our keys, and the open source project we have used just couldn't support the stronger keys, and the open source project was discontinued. So we had to take another approach, re-implement stuff, and so on. And this is the loop what we are currently are. We take the perfect decision today, but we know just how quickly the things are changing. So if I'm talking about technical debt, so I think about it, what can happen to our software, to our solution over the entire life cycle of our product. And of course, it's related to amount of code written. So the more code we write, the more we have to own and just to upgrade, but it's also related to the amount of dependencies we use and we also just manage and deploy. And say open source projects, like even simple dependencies, but also programming languages, database, web application servers, and so on. So everything that you are currently managing, then you have to take care about this. So another stuff which relates to what holds us back from being productive is just relying on legacy systems. And for me, legacy systems are systems that cannot evolve, just simply because you are stuck because of mainframe stuff and so on. You would like to move forward, but just only one person in the company understands this and so on. And now we will bring another definition, like evolutionary architecture. And this is the wonderful book released several years ago, Building Evolutionary Architectures by Neil Ford, Rebecca Parsons, Patrick Kua. So the people who are known for their work at ThoughtWorks, even many of them don't work there. And they are talking about just, write the architecture which support things like incremental change, appropriate architecture and coupling, and also fitness function. So the goal is just to move quickly and just be flexible. I mean, probably incremental change, appropriate coupling is things that are quite understood, but fitness function, it relates to stuff that it's also very common. It's just like source code metrics, like cyclomatic complexity, also unit test, percentage of coverage, performance tests, where we test our latencies and throughput, security in the cloud, if all your buckets are private, and also if you just do key rotation and so on. Also tools that just support CI/CD, it may be just your Jenkins or AWS suite with code commit until code deploy, and so on. So the goal is just to move quickly, but just have these checkpoints called fitness functions to see if something breaks. Yeah. And now we will be for the first time talking about serverless and how it may help us. And when I'm talking about serverless, I just always try to introduce the value proposition of serverless, just to see where it starts and where it may help us to be productive simply. So the first of all, just relying on serverless, and it doesn't matter on what cloud provider you outsource your infrastructure operation and maintenance as much as possible. And the question you have to ask yourself is infrastructure maintenance and operation your core competency? And probably the answer will be true if you are the data center provider, if you are cloud provider, but generally you are building products, and it should rely, of course, on the underlying infrastructure, just as the building block, but it's probably not your core business. And you will be happy if somebody with a big competency will help you. So the next question is just what serverless offers you: auto scaling and fault tolerance built in. And just ask yourself about, is it easy for your business to get capacity planning and auto scaling right? Yeah, and for us at IP Labs, we have just our Christmas business, that the people are just purchasing their products like calendars, like photo book on the year, and we see 10x and even more spikes. So for us, it was very difficult to do the capacity planning right, as we were in the data center, also because we are in the business to business white label. So we are relying on the capacity planning of our partners, and just these forecasts are not very accurate, and just we have to be able to react quickly. The next question is, do you want to solve the hard problem of fault tolerance by yourself with this all availability zones concepts and so on? With the data center, simply having active passive data center just on your own, it may be too expensive with all this stuff. Yeah, so just using all these concepts from the cloud provider and services like Lambda and so on, DynamoDB, this concept is built in from the beginning into the services, and it helps a lot. And also you see just the one more thing is just what prevents us of being productive is losses from software failures. And just I'm not talking about the deploying bugs and having quality issues, but just not to be able to serve your customer in your peak time, where you're losing probably much more money each minute that you have outages. So that's very important stuff, that this auto scaling and fault tolerance is built in. Another point is general, more broad term, own less, build more. And generally, by relying on the serverless managed services, first of all, you can do more stuff with the same amount of people. So the people have more time implementing your business ideas and so on than just taking care of infrastructure, of patching, of auto scaling and so on. And of course, you can more easily evolve your architecture if you just own less. So you focus on less, and then just you can think of doing things right. Another point is, and we just talked technical debt. So and with serverless, you lower technical debt simply because, yes, I like this quote from Paul Johnston, who is known in the serverless space: whatever code you write today, it will be your tomorrow's technical debt. So ask yourself and look at your code from 1 year ago, and you will say, oh, no, I don't want to write this anymore. That's totally logical because you are more experienced. You have learned a lot, but do we have time to do things twice and touch our old code? Of course, we cannot avoid writing code for our business problems, but we should write as few code as possible. So less code also means lower technical debt, and also less code means less maintenance. And just maintenance and technical debts are things that prevent us from being productive. And also think about this on this way: time and effort required for maintaining the solution over its whole life cycle is by far much more than only developing it. So from my experience, we are maintaining the solution 75% of the overall time, and only 25% we are developing something. And sometimes we are very quick at, yeah, just let's write this also, instead of thinking long-term, just, yeah, we have to own it, and probably some kind of software as a service, and or the service also from the cloud provider may help us, and it will be better from the total cost of ownership perspective. Yeah, of course, there's another stuff, everything owning less, lowering technical debt, it will allow you focus on your business value and innovation. And probably every organization wants like this. Yeah, so everyone wants to be innovative and just produce business value. And just, yeah, to close the cycle, this all will allow you faster time to market. And time to market is the key differentiator in today's business. So ask yourself, what is your core of your business, and what is the commodity utility, thinking in terms of worldly map, which have to be outsourced to other provider. Now, as we talked about serverless, just this is how we at AP Labs think about serverless, but this is general the diagram of serverless offering from AWS. You see lots of services there, and they may be more or less serverless. So sometimes AWS takes care of the whole management. Sometimes you need to do the stuff like for Kinesis and so on. But here on the right lower corner, you see the services that are more serverless. So just Lambda, DynamoDB in several modi, SQS for queuing, SNS for notification. And so what we are striving to do is to think about, can we solve the problem, yeah, with using these serverless services? And if the answer is no, and it may be some constraint, then we are going upper and look into the other offerings from the cloud provider, where we may probably take more operational responsibility, like like relational database, even container services, and so on. Now, in terms of how to measure the success, another book comes into play, and it just doesn't relate to serverless. It just relates to the software engineering. Probably everybody knows this book or read this already, Accelerate, from Nicole Forsgren and Jess Humble. And what they have asked themselves, and the last report is still 2 years ago, is just what makes the company successful, and in terms of quality and speed. And what they are measuring is just these components like deployment frequency, lead time for changes. These two metrics in green are related to the speed, and time to restore service and change failure rate there relates to the quality. And what the successful companies do, they don't sacrifice one for another. So they're quite good at just combining them. And just you see the metrics for the high performance companies, they even differentiate currently elite, but you just see the difference between deploying one time per month and deploying just several times per day if business requires it. And these are really good metrics, and these are, for me, even fundamental metrics for the software engineering. And but it's also just the question is how to achieve this. And then just we are talking about software delivery and operational excellence. And then you see the factors which contribute to being successful. And just you see cloud, yeah, using cloud, but on the right way. It's probably another talk. You can just use it for the wrong purpose. You see the code maintainability. For me, it just relates to the evolutionary architecture, but it also, for me, just serverless can help you to reduce this maintainability. It's also about loosely coupled architectures, and serverless architecture are mostly event-driven architectures, and they are decoupled by its nature. And it's also about disaster recovery testing. So best practices, monitoring, and so on, which are nevertheless very important for all kinds of applications. But just to see that the serverless very well fits into this picture. So let's do some examples. how you can solve some problems with serverless. For example, time to restore a service, it's just one of the metrics which may help you. So how can you restore the service in case something breaks, and just, yeah, at best completely automatic. And probably everybody is aware of a blue-green deployment where we have two environments and may switch from one into another if we just see the problems we have the previously working environment, or the canary deployment where we just continuously switching the traffic to the newer environment and just using two in parallel. And if we see something went wrong, just we can also completely roll back. So now we will be talking about some specific AWS serverless services which may help us. And everybody uses Lambda and API gateway. And of course, API gateway introduces stage variables and Lambda aliases. And also you can deploy Lambda alias and do traffic shifting. So just your API gateway points to the different Lambda version, and it's just simply very easy to automate stuff and say, okay, I just use this Lambda for some percentage of the calling. And then I can, if I don't see any errors, I may switch completely to using the newer Lambda version. So the same is also true. You can just do this, the canary deployment. So this AWS serverless application model, you can configure how you would like to roll out your solution, linear or with canary, and just you have these parameters. And you also may define alarms, so that pre-hooks, so pre-alarms before shifting, and also post-alarms. And in case that some alarm will be triggered, so then the automatic rollback will be started. So these are the concepts which are well known also outside of the serverless application, but serverless gives you all these building blocks just to implement this. But of course, there is a word of caution of this blue, green, and canary deployments. So switching the business logic is the one thing. So you have also to think about your persistence layer, like storage, like the database, that you don't break this. And of course, think about, do not make backward compatible changes in the file format or in the storage. Just if you just then go back, then it may break your application. And the same is also true, just do not make backward compatible changes to the database structures. Just don't rename table columns and so on, because just you cannot go back very easily, or just add not null columns. There is another book, like I think Evolutionary Database Architecture, which is 15 years old, but they are talking about these patterns also working on the database level with these iterations. So another metric which is very important and probably one of fundamental one. So the successful companies, they spend 50% of their time working on the new stuff. So and this is something that you have to measure. Does the serverless allow you to work this way? And just you see there are probably in your company, you can categorize this differently, but just security issues, working on defects and so on. This is something that just also relates to the stuff that you maintain. So measure this thing and just see how it works for you, but also one of the important metrics. So we also talked about briefly wordly map, and just to be short, what is this wordly map? There are two dimensions: visible stuff and invisible stuff. Just visible stuff is something just for what is visible for your just the product which is visible to your customers, and not the infrastructure behind it. And there are also, they differentiate between Genesis and also just Genesis custom built product and commodity utility stuff. And with each evolution in serverless is kind of evolution, because many things become commodities. So the whole compute stuff became commodity with the cloud itself, and now with the Lambda, the whole execution environment. So the whole web application server with managed programming language there also became commodity. Everybody can use this, but in order to be successful, you have to just also follow kind of what Simon Wardley calls co-evolution of practices just to become productive with this. So think if you are using NoSQL database and then just doing the stuff the old way, like you did it with a relational database, you won't be successful. So the same stuff applies also for serverless and all other stuff of evolutions. So first of all, just in order to be successful, you need to embrace the true DevOps. And there's also a link about this to DevOps topologies, which comes also from the same people who wrote the book Team Topologies. They describe patterns and anti-patterns working with dev and ops. And for the serverless, there is probably only one pattern which works very well if you have completely shared responsibilities with devs and ops. So you have ops people within the team. Complete infrastructure automation, it's true for serverless, it's true for every kind of cloud stuff. Chaos engineering becomes more important because the stuff breaks, and just you have to see how your application relies on this. But as serverless services are by default built in fault tolerance, it may help you, but in many cases you're not only using serverless services. So FinDev responsibilities in the team. So of course, the cost become one of the factors, and the cost may be unbounded with the serverless application. And of course, the team needs to just have access to the invoice, and just cost should be, yeah, like a feature like performance, like security should be one factor that you need to consider just in your backlog. But for this, everybody should understand the price models of the serverless and services and have yeah, the view on your spendings. It may mean not desired for your financial chief officer and so on. So then you have to talk, just otherwise the people won't be able to optimize. What we also see how to become successful with serverless, that each team or even developer may have its own AWS test account per feature or even per service. And yeah, that became that cheap because for serverless, you only pay for what you use, and you probably don't have too much storage in your testing environment and so on. So you may create these environments, you have to manage them, you have to delete them and so on. But generally, each developer can relatively quickly test the application on their own and just not breaking some stuff of others. We also see minimal local testing, so only functional tests. You have some local and so on. So you may do stuff, you may test stuff locally, but of course you're losing all these quotas, all this stuff that the cloud provider just like constraints and so on. But for very quick functional testing, it may be fine. And I also see that people currently adopting test in production for many cases, because only in production you have just your real workload. It's very difficult just to simulate something. So you have just to find the balance of testing on the staging, testing environments, but also embracing test in production. So currently we'll be switching and I will be giving you some example with AWS, how to do the stuff and so on. And we will focus on this stuff, own less, build more, and also lower technical debt. So I have another talk that I won't give here, which name is Writing Less Code with Serverless. There I will dive very, very deep into these examples, how to write this. I will only show several examples here in this talk. But general, there are several ways how to write less code with serverless at AWS. And the first one is just simply write less Lambda functions with your business logic. And one of the things how to achieve this is just to use AWS service integrations in case Lambda only calls the service and passes everything through and doesn't transform anything. And why it's important to write less function, or maybe important. Yeah, you write less code, so you have less to test, run, and maintain. Just you have also less CI/CD, deploy, rollback strategies, and so on to maintain. Infrastructure as code, IAM policies that should be attached to each function. Also permission stuff, it also reduces this. Lambda comes with cold start worries, so less Lambdas, less worries, less point of failures because everything fails and may be retried. Also less security concerns, such as if the Lambda can be attacked with some malicious event and so on. Also, you don't worry about the Lambda limits like concurrency settings per account and so on that you may consume. And also just less spending on Lambda and so on, because also CloudWatch and all third-party services for monitoring and so on, sometimes they rely on the number of Lambda calls. So it may also reduce your monthly bill, but may also increase depending on the situation. So another thing then how you can minimize writing your code is just write less infrastructure as code and use more meaningful abstractions, like frameworks like Amplify, like serverless framework components, and so on. So this is the whole list of examples that I will could give you, but I will focus only on the main stuff that you see the patterns how to reduce code with serverless on AWS. And the first one is just direct service integration. And for example, one of the services API gateway provides huge number of services that you can integrate. Nearly every service, simple QoS service, simple storage service, DynamoDB, and so on, can be integrated directly. This is the example from how we use that at IP Labs. We would like to centralize the ID generations for our product groups, and so on. We have customers in different regions, but just in order to avoid collision with IDs, we would like to manage them separately. And this is the example how API Gateway was integrated with Amazon DB, which simply manage these IDs for us. So yeah, we decide just to integrate API Gate with DynamoDB, and we write simple VTL template. It's probably very small, but you just can see which simply increments the desired ID and gives it back. So no Lambda. In Lambda, we can also call DynamoDB, but just it doesn't make any sense. Just write less code. Of course, you can say you write this in the template. You are right. Yeah. So nearly the same code will be here in the template, but just we eliminate one service from the equation, and this is a good stuff. So another example of service integration is with Event Bridge, which also kind of event bus decoupling consumer and producer, and it also allows you to do a lot of integrations. You can do integrations with the AWS services, just as the whole list. Yeah, you may integrate nearly all the services that AWS provides, but it also allows you to integrate with other services outside of AWS simply with the REST APIs. And examples of these services are Zendesk, PagerDuty, and so on. So just you can just integrate them without using webhooks and so on. So very powerful. We are using PagerDuty and so on. So very powerful possibility. The next one is, for example, event bridge filtering and routing. So you may use fan out pattern and just simple filter this on the consumer side, but event bridge allows you to define the rules. And in this case, we would like to filter by the attribute source with the value customer, my map, and so on. And so the consumer will only receive events which matches this rule. So also one of the very nice possibilities. Another thing that I mostly see currently what AWS provides is just visual tools. Yeah, for example, using AWS step function for workflow management. This maybe also could be difficult because you have to learn Amazon state language just to write this by yourself. So in case you're using this newly provided Visual Studio, you just can drag and drop the stuff. You may see what can be done for each service, what payload may look like. So it simplifies a lot the development. And I see this also for DynamoDB currently. I will summarize this and show you other examples. So another possibility also just to write less code is to use Amplify framework. And this is the framework which allows you to write the application quickly using AWS services, but also using web frameworks, JavaScript, React, but also mobile platforms like Android, iOS, or hybrid things, but also Flutter and so on. And they are going the same way, just they let you start very quickly. There is Amplify and admin UI where you can model your relationship, because just underneath there is a GraphQL for modeling the stuff. And another thing that I also see that Amplify offers you managed CI/CD. So this is another offering. So simply what you have to do is to say AWS, my code is currently in GitHub or in Bitbucket Cloud or in code commit from AWS, and all this pipeline for build, deploy, and deploy will be done automatically with the basic version, but that's totally enough. What happens? So you just don't need to think about writing these pipelines. So the common patterns, what I currently see is direct service integrations to reduce the amount of code written. And you have a lot of services which supports this pattern. API gateway I've shown you, event bridge I've shown you, but there are also HTTP API, step function, SNS, and also Amplify, all go to this direction. The second pattern is Visual Studio tool support and to reduce the cognitive load. So step functions, Amplify, DynamoDB, they provide you the tooling, just you can just do your stuff and just not learning some domain languages and so on. And also automated CI/CD to focus more on the business logic. You've seen this with the Amplify. Also serverless application model will also and currently also support some elements of this, but this is kind of the direction. Just and the direction is just very simply so how the future will probably look like. So all the code you ever write is the business logic. That's probably a very ambitious goal, but nevertheless, I think it's worth thinking about this, how to just focus on exactly this. So what serverless, just to wrap up, what serverless ecosystem gives you, with the right engineering practices, and I've shown you this kind of right architecture, monitoring, embracing of cloud, chaos engineering, and so on. It will reduce your extraneous and germane load that we talked about in the beginning. It also reduces the amount of code written and also reduces the amount of dependencies. So you don't manage execution runtime with Lambda. You don't manage also web application server with the API gateway, or just with DynamoDB, you don't manage your database and just freeze your time. But words of caution about this system. So reducing dependencies doesn't mean that you own nothing. You still own things, but probably generally less. So for example, Lambda runtime, they manage some versions of the programming languages, but from time to time they say, okay, Node.js lower than 10 won't be managed anymore. So you have several months just to upgrade, and it's your job to upgrade and make sure that everything works. Otherwise, AWS will upgrade on your own and your code probably will break. So Java 8 runtime should also currently be migrated to the Amazon Coretta OpenJDK version. So just the Oracle version cannot be used anymore. So this is also a job in case you need to do. And the same stuff is also with the database. If you don't use DynamoDB, but you use like Aurora with Postgres or MySQL compatibility, or you use directly Postgres and MySQL, sometimes AWS will force you to upgrade the database behind. So currently we got the notification that Postgres 9.6 will not be supported, managed version anymore. I mean, Postgres version 13 is released, so totally understandable. So we need to plan and execute this migration as well, in case we are using not completely managed databases. So this is, we have to take into consideration. So this is everything I wanted to tell you. It probably was a quick run, but I hope that just you can take some points from this and think about how you develop software. Is this the right approach for you? So for each companies, there are probably different constraints and so on. But generally, that's it. So thank you very much. And I will be happy to answer your questions. So Are there any questions? I don't see anything in the chat currently. So we have enough time, so I can wait several seconds and then, or even several minutes, or even see several colleagues. Yeah, hi, Elmar, in the room.
Hi.
And even Firdaus is here, so the half of the company.
Hi.
And Stefan Kaps is here, okay. So do you have any questions? So if no, then thank you very much and hope to see you at 2 o'clock. Then we'll be talking about embracing serverless for Java applications. Yeah, thanks, Yannick. I've read your message in the chat. Okay, now I see the first question. How is the onboarding experience with this approach? How does one know where to look in AWS? Yeah, it's a bit general question, but anyway, it's the ramp up phase. So just you have tens of services, and just you have to become familiar with this. So this is not that happens overnight. So we started with the very basic project with my colleagues and even with colleagues that are currently in the room. It always starts with something that is not business critical. For us, it was kind of calculation application that had only to be triggered one time per month, and it was kind of starting point for learning these services. Generally, there are 3 that you will use: API Gateway, Lambda, and DynamoDB. So this is the point where to start with. Sometimes you need something like SQS and SNS, or currently EventBridge became very popular. So start with this. Think about, do you have some kind of internal tooling that need to be rewritten or refreshed? Because it's also one of the good examples how to start with serverless, because all this tooling is generally only will only be used in your working time, and probably the utilization is quite low. So this is kind of characteristics that fits very well into this pay as you go, and just also not very business critical. So just not starting just with some huge application. That's probably, I can tell you to this, there are more than 200 AWS services. It may be overwhelming, totally understandable, especially if you don't have any cloud experience. Yeah, but just simply become familiar with those basic services. In any case, Johannes, you can contact me via email or via LinkedIn, and just we can continue the conversation, what may be important to you. Scrum, can you please give some information on the cost management on AWS? It seems a risk from broad perspective, that just you pay as you go, and just you have a fear that your invoice may be too much, or what is the question about the risk? Okay, high invoice. So it may be the case that if you have very, very high scaling application, then the invoice itself may be high, because just using lots of lambdas. But just you can also tune the application. You can also just take your invoice and see what parts of the application generate all those costs. You can just integrate alarms just to be notified as quickly as possible, of course. And but the invoice is one part, so think of the total cost of ownership also. And I think that the points that contribute to the total cost of ownerships are the developer salaries. So just compare this. Yeah, if you have people that can do more work, and then you pay to your cloud provider, but you can move more quickly, then probably you will value speed more over invoice. It may depend on the situation, but of course, just you have to take care about the invoice. Have I answered your question, or do you want to dive deeper? As a startup, there is time, not money, but I don't think that your startup has such a huge load or just consumes so much that the cost will be a factor, depending on the situation. If you are developing something, if you have only a few number of customers, I don't think that the cost will overwhelm you. You can write serverless application that costs you several pennies. Yeah, in case you have only just small customer base. Okay, other questions? Maybe questions from my colleagues? Okay, then thank you very much. Okay, then I see another question. Okay, oh, this is the comment from Firda from my Labs. Okay, but yeah, that's the trade-off. Do you need to understand this? Of course, the Amplify provides you some hooks that you just can adjust things if it doesn't go your way. But it's of course the trade-off. Just yeah, this the same things we ask ourselves as we used Hibernate. Just generated your code and just you lose a bit of control. But if it's good enough for you and just you can do your work and focus more on business logic, then that may be totally fine. But probably everything is a trade-off. And of course, just ask yourself, can you do your work, or do you need to understand something below this? Yeah, you can just also have AWS support and ask them questions in case you have some operational issues. But this is kind of trade-off between understanding the second level of abstraction, yeah, that you understand that something goes wrong in case, yeah. So for Kubernetes people, maybe it's very interesting. Yeah, it may look good if everything works, but if it breaks, then you have to understand the Kubernetes abstraction and just need to fix this. The same may be here too, but as long as the thing is managed, my position is just to trust AWS that they do their job, and they may do their job better than me for operational stuff for sure, and also for generating all this stuff. Okay, I got notification that I have currently only 2 minutes left, so probably the last question. Do you have questions?